All right, number 4. This is a case where the conjugate is going to be the best thing for us to do. And the way that I know that, the way that I know when to use the conjugate is that looking at this situation. Across the equal sign, when we look across the equal sign there, cosecant minus 1 and cosecant plus 1 are very similar binomials. Their only difference is that they are conjugates of each other. So when you see that happening, pick a side. Doesn't matter which side. I'm going to work with the left side because I've been working with the right side. And multiply that side by the conjugate. I have had a lot of students in the past tell me, like, well, I would never know to do that if you didn't tell me. This is one of those things that you've seen a couple of these. This is kind of something that you need to have in your little kind of go through the list. Can you do a common denominator? Would changing everything to sines and cosines help? If you hit a wall, this is something to try. And once you've seen it a couple of times, it kind of flows that you should use it. Now, what I'm not going to touch in this problem, since I've created it, and this is legal because I'm doing the same thing to the top and bottom of the fraction. I'm multiplying by 1. And so I can multiply by cosine minus 1 over itself. Or cosecant minus 1 over itself. I can multiply by anything over itself. It's legal since we're just multiplying by 1. This cosecant minus 1 in the numerator is part of my goal, right? It's on the other side of the equation. It's on the other side of the equal sign. So I'm going to leave that alone. I'm not going to multiply that cotangent in. I'm just going to work with the denominator, and I'm going to try to get the denominator to match the other side. So I'm going to see if I can turn that denominator into cotangent. That is a single cotangent. That is my goal. So leaving the top the way it sits, I'm going to multiply out the denominator. So cosecant times cosecant is cosecant squared. Cosecant times negative 1, negative cosecant. Cosecant times positive 1, positive cosecant. Positive 1 times negative 1 is negative 1. Again, I'm leaving the top alone. In the denominator, my middle terms cancel. So I'm left with cosecant squared minus 1. I want to be able to get rid of the squared. I want to be left with just a cotangent. And that should kind of jog your memory. You should start thinking back to those Pythagorean identities that we know. So sine squared plus cosine squared equals 1 is our big one. But there is one that links cotangent squared and cosecant squared. If you couldn't come up with that off the top of your head, the way to get there is this. Everyone has sine squared plus cosine squared memorized. If you want the identity with cosecant in it, then you need 1 over sine squared, right? That would give you cosecant squared. So if you're going to divide by sine squared there, you've got to do it everywhere. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And then in order to get cosecant squared minus 1, we would subtract the 1 over. So cotangent squared is equal to cosecant squared minus 1. So I can put cotangent squared in right there. Hopefully the first 4 examples here, if you hadn't put the time into memorizing those Pythagorean identities, hopefully those convince you that it's worth your time. Cotangents cancel, just one of them in the denominator, and then we match the other side. Cosecant theta minus 1 over cotangent. Memorize your Pythagorean identity.